Hi students, so this is another lecture where we will solve few numericals of type E based on the formula electric power. Now see, before solving the numericals, first we need to know few things like what is an electric meter, what is an electric power, their units, etc. Okay, so see what is an electric meter first. Now it is nothing but a device that measures the amount of electric energy consumed by any electrically powered equipment. Okay, here the unit is given in kilowatt hour. Now next see what is an electric power. It is the rate at which electric energy is dissipated or consumed in an electric circuit. Now electric power means it is the amount of electrical energy consumed per unit time. Okay, here the electrical energy consumed per unit time is your electric power. Now power equal to, we know that work by time. Therefore the electric power will be your energy consumed by time. Is that clear now? So energy consumed equal to power into time. Now write the unit of electric energy. For power it will be your, what is the unit for power? The unit for power is watt, and for time it will be in second. Okay, now energy consumed in bigger units will be kilowatt into hour. Here watt will change into kilowatt and second will be in hour. So 1 kilowatt into 1 hour will be your 1 kilowatt hour. So that is the 1 unit. Okay, here the energy consumed in bigger units equal to 1 kilowatt hour. Alright, now see the relation between commercial and SI unit of work. Here 1 kilowatt hour equal to 1000 watt into 3600 seconds. So see here 1000 watt means kilowatt. Okay, and here H, that is in hour, we have to convert it into seconds. So therefore it is 3600 seconds. Now 1 kilowatt hour equal to 36 into 10 to the power 5 watt second. Now kilowatt hour equal to 36 into 10 to the power 5, it will be joule. Alright, so 1 kilowatt hour equal to 3.6 into 10 to the power 6 joule. So this is the value for 1 kilowatt hour, 3.6 into 10 to the power 6 joule. Okay, done. Now see here we will solve the numericals and we will use the formula, the electric formula equal to your energy consumed by time in hours. Now take a note here, the electric power should be in kilowatts, okay, not watts. It should be in kilowatts, and time should be in hours. If there is in watts or in seconds, we have to convert it into kilowatts and hours. Don't forget that. Now let's solve the question number 1. An electric refrigerator rated 400 watt operates 8 hours per day. What is the cost of the energy to operate it for 30 days at rupees 3 per kilowatt hour? Okay, here write what are the given values. Power is given, that is your 400 watt. We have to convert it into kilowatt because it is given here in watt. Now 400 divided by 1000 kilowatt, we will get 0.4 kilowatt. Here time, it is already given in hour, but for 30 days we have to multiply it. 30 into 8 hour equal to 240 hour. And the cost per kilowatt hour equal to rupees 3. So what we have to find out? We have to find out the energy consumed. Now formula we will use, energy consumed, we know that it is power into time. Okay, now let's solve it. Energy consumed equal to power into time. Therefore it will be, for power it is 0.4 kilowatt into, for time it is 240 hour. So energy consumed equal to 96 kilowatt hour. Is it clear? Now see here the cost of energy will be 96 into rupees 3. So that is the cost of energy equal to rupees 288. Okay, done. So the answer is, the cost of energy to operate the refrigerator for 30 days is rupees 288. Easy? Alright.
कोई भी सपना साकार करने के लिए सबसे जरूरी है सही कोच का होना। चुनिए नक्षत्र को और करें अपनी 4th to 12th classes and government preparation का Sapna Sakar. Download the app now.
Now question number 2. An electric heater rated 1000 watt and a potential difference 220 volt operates 2 hours daily. Calculate the cost of energy to operate for 30 days at rupees 3 per kilowatt hour. Alright, now write what are the given values. Power P equal to 1000 watt. Now convert it into kilowatt. So we know that 1000 watt equal to 1 kilowatt. Now time T equal to 2 hours per day. Okay, so it is already in hours, so we don't have to convert it into second. Now we have to find out the cost of energy to operate for 30 days. So the formula we will use, energy consumed equal to power into time. Alright, now put the values. For power it is 1 kilowatt into 2 hours, so it is 2 kilowatt hour. Now what is the cost of energy to operate? Cost of energy to operate equal to 2 into 3, that is your rupees 6 per day. Now the cost of energy to operate for 30 days will be your rupees 30 into 6 equal to rupees 180. So the answer is cost of energy to operate electric heater for 30 days is rupees 180. Move to question number 3. A 100 watt electric bulb is lighted for 2 hours daily and 441 bulbs are lighted for 4 hours every day. Calculate the energy consumed. So there are two powers given. So we will write power P1 equal to 100 watt. Convert it into kilowatt. So we will get 0.1 kilowatt. And time T1 equal to 2 hours. And the power P2 equal to 40 watt. So convert it into kilowatt. 40 divided by 1000 kilowatt, we will get 0.04 kilowatt. Now time T2 equal to 4 hours. So what we have to find out? We have to find out the energy consumed in each case. Alright, so the formula here, energy consumed equal to power into time. Now let's solve it. Energy consumed equal to, we will find out for power 1 and time 1. Okay, now put the value 0.1 kilowatt into 2 hour. So we will get 0.2 kilowatt hour. So energy consumed by 100 watt bulb in 1 day is 0.2 kilowatt hour. Now for the second case, energy consumed equal to 4 into P2 into T2. Now here see there are 440 watt bulbs, right? So we will multiply it with 4. So 4 into 0.04 kilowatt into 4 hour. Energy consumed will get 0.64 kilowatt hour. So energy consumed by 440 watt bulbs in 1 day is 0.64 kilowatt hour. Clear? So what is the total energy? Total energy consumed will be your 0.2 plus 0.64 equal to your 0.84 kilowatt hour. So the answer is total energy consumed is 0.84 kilowatt hour. Okay, done? Let's move to question number 4. Which uses more energy? A 250 watt TV set in 1 hour or a 1200 watt toaster in 10 minutes? Okay, interesting question. Let's see. Write the given values. First, power P1 equal to 250 watt. Convert it into kilowatt. We will get 0.25 kilowatt. Now for power P2, that is your 1200 watt. Convert it into kilowatt. 1200 divided by 1000 kilowatt, we will get 1.2 kilowatt. Now the time T1 equal to 1 hour and the time T2 equal to 10 minutes. Okay, convert it into hour. So 10 divided by 60 hour equal to, we will get 0.167 hour. Now what we have to find out? We have to find out energy consumed. Okay, so formula we will use energy consumed equal to P into T. Well, now energy consumed by a 250 watt TV set in 1 hour equal to P1 into T1 for the first case. Okay, so put the values now. 0.25 kilowatt into 1 hour, we will get 0.25 kilowatt hour. Now energy consumed by 1200 watt toaster in 10 minutes for the second case, this one. Now P2 into T2 we will get after putting the values and multiplying it, 0.2 kilowatt hour. So the answer is energy consumed by a 250 watt TV set in 1 hour is more than the energy consumed by a 1200 watt toaster in 10 minutes. So see here, the energy consumed by 250 watt TV set in 1 hour is more than the energy consumed by a 1200 watt toaster in 10 minutes. Alright. Now see, this is the last question of this lecture. So a household uses the following electric appliances. First one is refrigerator of rating 400 watt for 10 hours is day. Second is 2 electric fans of rating 80 watt for 12 hours is day. And the third is 6 electric tubes of rating 800 watt is for 6 hours is this. So what we have to calculate? Calculate the electricity bill of the household for the month of June. If the cost per unit of electric energy is rupees 5 per kilowatt hour. Alright, let's start. What are the given values? Write all the powers. For P1 equal to 400 watt. Convert it into kilowatt, we will get 0.4 kilowatt. And the time T1, 10 hours per day. Okay. Now for power P2 equal to 80 watt. Convert it into kilowatt, we will get 0.08 kilowatt. And at time T2 equal to 12 hour per day. For P3, we will get 18 watt. Convert it into kilowatt, that will be your 0.018 kilowatt. And T3 equal to 6 hour per day. And the cost per unit of electric energy is rupees 5. Now what we have to find out? We have to find out the electricity bill of household. So the formula is same, energy consumed equal to power into time. Let's solve it. Now for the first case, the energy consumed by the refrigerator is P1 into T1. Put the values and multiply it. We will get 4 kilowatt hour. Now for the second case, the energy consumed by 2 electric fans. Multiply it with 2 into P2 into T2. So we will get, after solving this, 1.92 kilowatt hour. Now for the third case, energy consumed by 6 electric tubes. Now multiply with 6 into P3 into T3. Put the values, then we will get the energy consumed by 6 electric tubes is 0.648 kilowatt hour. Now what is the total electrical energy consumed? Now add all the electric energy consumed. So after adding all the energy consumed, we will get 6.568 kilowatt hour. Now see how many days are there in the month of June? 30 days. So energy equal to 6.568 kilowatt hour into 30. We will get 197.04 kilowatt hour. So therefore the electricity bill of operation is 197.04 into 5. And it will get rupees 985.2. Alright, so the electricity bill of household for the month of June is rupees 985.2. So this is all about our today's lecture, number 10 of your electricity chapter. So share the link among your friends if you found it helpful. Also sharing is caring, right? Anyways, download our app Nakatra for live classes, and also you can do the doubt classes. Even you can give the online exams to test yourself. So download it. The link is given in the description box below. So this is all for today, students. Bye bye. Thank you.